So today we're going to talk about cranes. We're going to start off with a little bit of a refresher on how we take apart gas holders, because it's fairly important as to what the cranes do and why we use them. So with a gas holder demolition, specifically a man gas holder, which is the big ones that you used to see at Battersea, Southall, Liverpool, many other places around the country. I don't think there's any left in the UK. There might be some in industrial plants, but all of the city centre ones have gone now. So within a man gas holder, you have a piston at the bottom. Gas used to be pumped in at low pressure underneath that. That lifted the piston, and the piston then provided the downward force to push the gas out into the gas mains when we use low pressure gas mains. When we demolish these structures, we use that piston, blow it up to the roof, sit the roof onto it with a frame or some timber stack, whatever suits the exact arrangement. Then we cut the roof free, and that becomes the working platform, and that's floating on a bed of air running at about 3 cubic per square metre maximum pressure. And the cranes sit on that, and we then use those to dismantle the gas holders. The cranes themselves sit on a crane rail system that allows them to go around the full perimeter of the structure. So in plan, it looks something like that. Now, these man gas holders vary from, I think, about 45 metre radius through to 60 odd metre radius, depending on who built them, when they were built, etc, etc. So in plan, it's something like this. We normally had a pair of cranes up there. These could operate next to each other, one with man ride and one lifting panels down. They could lift around 2.5 tons. By the time we'd finished with these, when we did the final one at Southall, and behind them you then had a working platform, or in front of me you had a working platform for people to work on, and at the back there you've got a track for the back wheel of the crane to run on. So these cranes, this is back in, I don't know, maybe 2011. This was the first ones we did with Coleman's up in Liverpool, where we designed these cranes the first time. There you go, you can see there, that was 1.5 ton was our safe working load back then for the first version of these cranes, and they weigh about 2 ton. They sit and they run on a crane rail around the perimeter. As I said, you can see it here. Let me find a little pointer. Where's the pointer? Spotlight, there we go. There's the rail there. It runs around, and you've got a little jockey wheel at the back there. So when these cranes aren't lifting, they sit back, they rock back, and the jockey wheel there sits on a track that runs around the roof. When they're lifting, they have what we call the backstay up here, and this goes back to the central pivot in the middle of the holder itself. So the tension load goes back there, and then we can lift from right in close all the way out to allow us to drop the panels down to ground level. So this was, say, the first iteration that was designed, and they developed over the years to be able to lift heavier loads at a greater radius. Let me clear my screen. That's the mouse. Now, when these cranes are in operation, they're obviously sitting on rails normally, and they were propelled along there with a little motor. Now, when you comes to lifting, you want to be able to lock these cranes in place, so the crane itself isn't trying to move. And equally, if there's a storm coming in or bad weather's predicted, then you want to be able to lock these cranes in place. Come with a little brake detail there that clips onto the crane rail itself. So this is the backstay I was talking about here. Get my pen. Crane rails here, edge of the holders here, and this is the shell plate that we were dismantling down here, and the backstay in the centre there. So when this picks up the load, the tension is transferred back to the backstay in the centre there, and then that's taken via these struts. Well, I think it might have been tension cables going in 4 directions back into the truss itself. So obviously the truss was analysed for the weight of the crane when it was operating, plus the loads that are put into the truss by these by the backstay itself. Just cleared that, try that, there we go. So this was pretty much the final version of the crane itself. So this was, by the time we got to Battersea, which was the second from last crane, The safe working load had gone up to 2.5 tonne, which had meant part of the jib had been redesigned and strengthened, and we'd increased the working radius as well to make life easier, because as these things were used over, I think it's 4 or 5, maybe 6 man holders. Obviously, Coleman's learned, or we learned as we went along, what we needed to do to make life easier. So by then they were quite a good little crane. So there's a pair of them up on the roof, and they worked very successfully to allow Coleman's to dismantle the gas holders in a safe manner, including on some sites with some very restrictive neighbours such as Network Rail and the like. Now, the cranes went through a bit of an evolution. Similarly, the crane rails that they sat on went through an evolution. So going right back to the first version back in 2011, this was on one of the gas holders in Liverpool, which were quite small. The radius of them was quite small. So the first version that was designed was just using steel angles, and then a crane rail on top of that for the crane to run on. This then evolved into to make it a better strength and weight ratio. This evolved into a pressed steel, lightweight, fabricated track. So you're only talking about 6 metre spans on this one, so they weren't massive. And we could design these, get these to work about 400 kilos for a 6 metre span to allow, I think it's point there is about 4 tonnes in the centre. And you can see the first version there, so you can see it's actually quite small, about 6 metres in the crane, comparison to the crane there. So this is where the piston has been allowed to drop down within the gas holder. So what you can see there is the inside of the shell plate. So this could be when we were just about to change the high reach, I think, but I can't remember off the top of my head. And on these early ones, you can see there's no working platform as such, and there's no real track at the back end for the jockey wheel to run on. But again, as things went on and we found different issues with the holders, the schemes developed. The next one, I think this was at Battersea. Yes, this is Battersea now. So at Battersea, we wanted to reuse the original crane rail. So you can see there, one of the crane rails, one of these crane rails here has been reused, had new flanges put on it. And then we designed these little infill pieces here that you can see in the top right of the screen, put those together, and that gave us another 1.5 meters, maybe 2 meters from memory, to make up the larger radius on these holders, which allowed us to reuse what we already had, what Coleman's already had fabricated with a minimal effort and save time, cost, money. And there it is. That's definitely Battersea. You can see the Battersea chimneys in the background there. So you can see the infill pieces there and the original slightly modified crane rails just there. And there's a close-up of the detailing. And these structures are working quite hard, and they're very, very stiff structures for their weight. The next version was at Southall, which was a bigger holder again. Originally, the brief was to try and keep them a set size so we could move them up in a hoist and then move them around fairly easily. That moved on. The fabrication costs of that added up because there's quite a lot of detailing to make them stiff enough and make the connections work. That moved on to, all right, we'll make them in one piece, but we'll lift them up when we lift the crane up. So that became a one-piece solution. You can see there we've reduced the depth for 2 reasons. First, you didn't need it for bending capacity, and secondly, it made the detailing of the working platform easier. I think these and Southall were actually designed in FEA using SolidWorks, because it just gives you a nice, clear representation of what's happening with the stresses in the structure, which is a lot easier to picture when you start working with like quite lightweight, thin gauge steel sections. However, it was checked to 59550 part 6, which is the thin rolled cell thin section. Obviously, all passed that. And yeah, there you go. You can see in operation. So this was Southall. This was the last one that was done. You can see a nice big working platform at the front here. See the crane rails at the back, and then you can see the jockey wheel platform at the back here. So that there is for the jockey wheel to roll on when it's sitting backwards, and that's what the crane sits on there. And that there is the shell plate that's been demolished. This is just some pictures. So that one's obviously back at Battersea because of the crane rail. That's Battersea again. See the generators that are lifted up on the roof to run the cranes. You see one of the hoists there. So the idea was everything could be, not everything, that all the crane rails, all of the working deck bits and pieces could be brought up within the hoist, which limits the craneage required. So then you only need a mobile crane to come in and lift these cranes into position, which again saves time and money. This is going right back to one at Liverpool St Helens, one of the earliest crane rails you can see there. And there you go, there's a picture from the backstay itself, and you can see the cable that goes up to the top of the crane, and that goes into tension when the crane is loaded. And you can see there the process of the shell plate and the columns being removed. So you can imagine as that crane comes round to the right, if I didn't press the button, that get there in a minute, that panel there then gets lifted out, then that panel there, then that column there gets lifted out and carried all the way around the holder. And the idea with these cranes, you could have one could be set up with a man rider, so for a basket to be hanging off the edge, and then the other one could be lifting and they could sit right in the same base. So you had some quite significant loads put down onto these crane rails. And they played an important part in the demolition works, that's for sure. There you go, panels being lifted down, column sections being lifted down, and there you can see some of the extra steelwork you find on the outside of these structures, like the walkways and things here. So that's why we had to have the crane set up, so you could have a man rider sitting next to the one lifting, so the man rider could go over and burn these sections free to allow the other crane to lower them away. Again, that was all learning from as these projects went on. So now we're on to the cranes of New Street. Again, a fairly old project, but probably one of the most impressive in terms of cranes. These and the gas holders are the ones we've done, where we've designed specific gas holders. See one of the cranes in action there. Another job for Coleman's. I'm going to start that again. There we go. So again, a little bit of background as to why the crane solution was selected at New Street. This is a cross section through station. Platform level is, let me get the pointer again. Let's try that one. This is platform level down here, and this is the floor with demolition here. And that's concourse level here. So that level there had quite low capacity, or originally we were only allowed to put very lightweight plants on it, making it very, very difficult for us to, or for Coleman's to complete the demolition in any sort of time effective or cost effective manner, which is why the option of cranes was first selected. So again, looking crudely through the structure, the level to come out is those grey beams. The yellow level below is the floor, which is of limited capacity. And then we've got to take all of that structure there out. So you can see some fairly hefty beams in there. So the solution was where these red lines are here. I'll try again. I'll get the right pen in a minute. Where these red lines are here, 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 there and there. They are all crane rails that run the length of the building. And you can see there, that yellow there, there, and there represent the gantry cranes that were designed to sit and run in the structure to allow us to take the structure apart. So in plan, something like that. So you can see the same structure laid out below, the same basic hatches in place, and then the crane rails. And the idea with the crane rails is they sat onto the little stubs of the column, the beams that come off the column that were part of the floor we're demolishing. So if you imagine you've got a column, if that's your column, and then you've got a beam that goes across here and a beam that goes across here, our crane rails sit here and here, and the same on the next column across there. That meant that we could then demolish up to this stub here whilst keeping the crane rails supported, and then you could take these stubs off afterwards. That was the basic principle, and that allowed this floor to be dismantled and cut to pieces, as you've seen in those videos. And there you go, another section looking the way where you can see the crane rails in elevation or section there, and the gantry train itself up there. There's also this system where we had to move. We couldn't bring all the crane rails out the front of the building or the side of the building, depends which way you think of it. So we had to move some from left and right to the other crane where it could come out the front of the building. There's the transporter. So crane rails themselves were fairly hefty fabricated sections. They weren't that hefty, but they obviously did the job. There's some quite large spans, as you can see there. And we were talking about lifting 10-ton lumps. By the time that's got all the appropriate factors on it, it ends up being quite an onerous load that you've got to design the crane, the structural design of the crane, which we did. Obviously, all the electrics and mechanical side of things is done by the people who specialise in that sort of thing, but the structural design was ours. And then the same with the crane rails, fully designed and detailed, plus the assessment of the structure itself to justify that the loadings weren't increasing on the structure as the demolition was undertaken. There's another nice little view. And again, because the floor below was quite a low capacity, we couldn't prop the beams down to the floor below. We had to put these trusses in that allowed the beams to be sliced up and then lifted out of the crane. And you can see what I was talking about there quite nicely. You can see the stub of the brickwork that gets left in brickwork, sorry, the stub of the concrete there that gets left in place, on which the crane rail sits, and then these get taken out after we take the crane rail back out. And there's just another nice little elevation of the crane in action. So you see they're quite a low headroom. That all had to be quite well thought out to make sure the correct hoists and things were selected for the low headroom, make sure we could actually lift the slabs out as we required. You see there a nice 10-ton lump of concrete slung. You can see how tight everything is, pulled all the way back up with the hoist block basically touching the hoist itself. So this is where I was talking about the transporters. So this area here is where we could load. I'll get the hang of this in a minute, won't I? Finding it very difficult today to collect the pen to work. So this here is where we could load with lorries. So lorries could run through here, but they couldn't run through this bit here. We couldn't block that area off. So we had to bring the sections up to here and then across the building and then out there. Not really do with crane design, but There you go. And there's an elevation showing where it comes out of the structure. And there it is in reality. Lumps of concrete loaded onto the back of a lorry and away. That kind of brings us to the end of the crane design segment. I'm sorry if you expect me to go into detail of how we design a crane, but I thought it was a little bit beyond the scope of what these webinars are about. So these case studies are based on interesting lifting arrangements, shall we say. So this is quite a recent project. This is a signal box called Spooner Row in Norfolk. There's a series of 4 signal boxes being demolished, but this one, something special about it, I'm not sure what, but the North Norfolk Railway requested, or gave it to the North Norfolk Railway. So we're tasked with coming up with a way to allow all the timber structure, so that bit there, to be removed in one go, so it could be taken to the North Norfolk Railway and sat on a new brick base, as I understand it, so it's preserved for future. So, as ever, contractors want cost-effective, simple solutions to things like this. So we came up with quite a simple scheme whereby we needle into the masonry here and here, both ends, and that allowed sleepers to be put in here, and the same the other end, there and there. And then we could sling around and underneath, so you cut pockets in the masonry there, and there. Does this vanishing pen look all right, Chris? Has it come out okay? Or was it disappearing too quickly?
It looks okay.
It's right. So that allowed the slings to be put in and underneath. You can see there. So you imagine they go down, around, under those timbers, up and back up to the crane itself. That's just a bit more of a detailed view on it. And there you go. So this is the sleepers I was talking about here. There. And the idea of those is they spread the load into the floor joists, which span left to right. The floor joists themselves were notched into, or they were built into the timber frame, the structure. So by picking up the floors and by picking up this edge here and this edge here, we knew we could lift the structure up in a safe manner. So luckily, and for a change, we've got quite a nice video. Not very often we get this. See the holes being knocked in there for the sleepers and the lifting gear to go through. There you go, nice and easy. And away it went on the back of a low load up. Yeah, so it's not very often we get quite such a nice video, especially so shortly after the event. It only happened a few weeks ago, so nice to see, and good to see that it all went swimmingly and as we expected it to. So another interesting one in terms of lifting. So this was a scheme where we did the crane position and also the demolition of this footbridge. So this was quite an interesting footbridge at Crawley. Had some strange detailing, not what you would call a typical concrete footbridge. Quite a restrictive site in terms of access, so the preference was to cut and lift the bridge out, because the platforms were precast, so plant access wasn't great. It just made more sense to get the crane in there and cut and lift it into pieces. So the concept with the whole plan of this demolition sequence was that it was to be curtailable as far as possible. So we had to look at and consider stability at quite a lot of stages throughout the works and demonstrate that we could stop the works if required. There would have been a little bit of messing around to do, but the client was fairly adamant that they wanted to be able to stop. So first thing to come out was the top flight of stairs, clearly leaving a nice stable lower stair. We assessed the bridge standing like that, and it was quite happy. And then the proposal was to saw cut it. Again, that was done by wedging. So the whole thing could be saw cut and sat there ready to go, sling it, lift it, and away you go. So if we'd been winded off for whatever reason, or whatever happened that curtailed the possession, it could have been stopped, and we could have put some straps in place to hold it, lifted out in nice easy sections. Sorry, that would be my dog going crackers because he's heard a squirrel in the garden. So there's some pictures of the works being undertaken, coring work ready so we can sling and lift it, the saw cutting itself, and then there's a section lifted up and away, and there's the main span itself coming out. And again, the weights were bang on, which was good, always good, and the lift plan went exactly as we said, which was great. Job was completed on time, which is what everybody wants. That brings me to the end of the presentation today, short but sweet. And we'll now take any questions. If you want any more information or want to some background reading, they're the places to go as usual. And then this one, if any of you are involved in or want to know a bit more about how load factors, etc., what we need to do for fabrication of lifting accessories, not cranes specifically, but lifting accessories, that is the place to go, which is the BCSA publication.